Hi, I am Rashani DeBell, and you are learning algebra. Hi everyone! Today we're going to learn how to solve a system of equations using substitution. So let's get started. Remember when you were given the equation x plus 3 and asked to simplify it when x is equal to 2? Well, you would simplify this equation by plugging in x equals 2 for x and solving it and getting 2 plus 3 equals 5. The idea is the same when you are solving a system of equations. The only difference is that instead of x equaling a constant like x equals 2, we now have x equals to a constant and a variable such as x equals 2 plus y. When do you use substitution? Substitution is used to solve a linear system when there is an equation that has a variable with a coefficient of 1 or negative 1. For example, in this system, 6x plus y equals negative 5 and 2x minus 3y equals 10. You'll see that this equation over here has a coefficient of positive 1. So it would be easiest to isolate the y in equation 1 because the variable has a coefficient of 1. The steps to solve a linear system using substitution is as follows. Step 1. Isolate a variable from one of the two equations. In this example, I have x plus 2y equals 4 and 2x minus y equals negative 2. It is easiest to isolate the x from equation 1 because it has a coefficient of 1. I do this by subtracting 2y from each side and I get x equals negative 2y plus 4. Step 2. Substitute the expression from step 1 into the other equation and solve for the other variable. What I mean by this is I am going to take this revised equation of x equals negative 2y plus 4, and where x goes in equation 2, I am going to replace it with negative 2y plus 4, which is what I've done here. So it's 2 times negative 2y plus 4 minus y equals negative 2. I am now going to solve this equation for y, and when I do that, I get y is equal to 2. Step 3. Substitute the value obtained in step 2 into the revised equation from step 1 and solve. This is my revised equation, x equals negative 2y plus 4. I am going to take the value of y equals 2 and substitute it into this equation and solve for x. When I do that, I get that x is equal to 0. Step 4. Check the solution by substituting the x and y values into the original equations. Here's my check. Where x goes, I'm going to replace that with the value of 0, and where y goes, I'm going to replace that with the value of 2 and simplify the equation to see if it makes a true statement. In this first equation, 0 plus 2 times 2, which is 4, gives me 4, so it works. In the second equation, 2 times 0 is 0, 0 minus 2 is negative 2, and it works in the second equation. Therefore, my solution to this system of equations using substitution is x equals 0, y equals 2. Now, let us work through a few examples. In this equation, we are asked to solve the linear system. We're given the equations 2x minus 5y equals negative 13 and x plus 3y equals negative 1. Our first step is to isolate a variable from one of the two equations. Looking at these two equations, I can isolate this x plus 3y equals negative 1 because the coefficient by x is 1. So that's what I'm going to do. Step 1 is isolate x. Start by subtracting 3y on both sides. These are not like terms, so I can't combine them. What I'm left with is x equals negative 3y minus 1. I am going to call this my revised equation 2. So RE2. Step 2 is to substitute this expression into the other equation and solve for the other variable. So do that in blue. I am going to take x equals negative 3y minus 1, substitute it into the first equation 2, and instead of x, I am going to put negative 3y minus 1 minus 5y equals negative 13. And now I'm going to solve this equation for y. So distribute. I have negative 6y minus 2 minus 5y equals negative 13. Combine my like terms. They're the same sign, so I add and keep. Negative 6y plus a negative 5y is negative 11y. Minus 2 equals negative 13. Isolate the negative 11y by adding 2 on both sides. I get negative 11y is equal to negative 11. Solve for y by dividing every term by negative 11. And y is equal to negative divided by a negative is positive, 11 divided by 11 is 1, y equals 1. Step 3 is to substitute the value obtained in step 2 into the revised equation from step 1 and solve for that variable. So let me go ahead and label our steps here. This is step 1, this is step 2, step 3. In step 3, I am going to substitute the value that I obtained in step 2 into the revised equation of step 1 and solve for this variable. So I'm going to take y equals 1, plug it into this equation, x equals negative 3 times y minus 1, and solve it for x. So here we go. X is equal to negative 3 times 1 minus 1. Negative 3 times 1 is negative 3 minus 1. Same sign, add and keep. I get x is equal to negative 4. Therefore, my solution to this equation is x equals negative 4, y equals 1. I need to check my solution to make sure it works for both systems. So here's our check. This is step 4. Start with the first equation. 2 times negative 4 minus 5 times 1. Is that equal to negative 13? 2 times negative 4 is negative 8. Negative 5 times 1 is negative 5. They're the same sign, so I'm going to add and keep. Gives me a negative 13, which is equal to a negative 13, so it checks in the first equation. Let's check on the second equation. Make sure it works on the second one as well. So I have negative 4 plus 3 times 1. Does that equal negative 1? Negative 4, 3 times positive 1 is a positive 3. They are different signs, so I subtract and I get negative 1, which is equal to negative 1. And so yes, this is our solution to our system of linear equations. I would now like you to try a problem on your own. Here's the problem with the steps. Pause the video over here and work through the problem. When you are done, you can check your work by watching part 2 of my lesson on how to solve a linear system using substitution.